Hello, welcome. Let's try to solve another Leetcode problem 998, maximum binary tree 2. I think most people cannot solve the problem is that they don't understand it. So if you understand the problem, definitely this is going to be an easy problem. So let's just try to understand it. So the maximum tree is the tree where every node has a value greater than any other value in its subtree. And it's easy to understand. For example, this node 4, it's going to be greater than all the other values like 1, 3, and 2. So this is the meaning for the first sentence. So we are also giving the root of the maximum boundary tree at integer val. So we are giving the root and we are giving a val. Now we need to understand it as the previous problem. So the given tree was constructed by a list, but currently it is a root of the tree. But actually we can understand it as a list. So it's going to be recursively with the following construct A routine. So this is going to be exactly the same like the previous problem. So if A is empty, we're going to return a none. And this is also telling us how to write the recursive function. Otherwise, let AI be the largest, and we're going to create a root node with the value of A. So this is just like what we build the tree from the array. Yeah, the left side is going to be A0 to AI minus 1, and right side is going to be A plus 1 to A less minus 1, and we're going to return the root. And we should also know that we are not giving A directly, only a root node, and B is going to be a copy of A with the value of val appended to it. So it is guaranteed that B has a unique value. So how can we understand? Let me just use an example to explain. Maybe the first example. We should know that this kind of a tree structure is built by array, and the array is just from this. So we are having a let me maybe use another color. Maybe it's better to explain. So we are giving the first value 4. This is the node 4. This is going to be the root node. And at the left side, there's going to be this node 1. So we're going to put a 1. At the right side, it's going to be 3 and 2. So we're going to have a 3 first. But at the left side of a 3, we're going to have a 2. So 2 is going to be here. Yeah. So this is our array. Now what are we going to do? We want to append value 5 to the array, so the 5 is going to be here at the end. So if we put a 5 here, so what is going to be the final result? As we know, according to this kind of a structure to build the maximum boundary tree, so we're going to first find the maximum value 5, and this is going to be the root node 5, and its left side going to be the subarray. So this subarray going to be at the left side. So this is this is the meaning of the problem. Now let's just continue to check the second example. And similarly, we're going to first find the root node, which is going to be 5. At the root node is going to be. So we're going to first find the we're going to first find the root node, which is going to be 5. Then we're going to check the left side and the right side. Yeah, so for the left side, according to this kind of drawing, we should know that we're going to have a node 2 and 1. So where is the 2 and 1? Let's just write the right side first, because at the right side there's node 4. We're going to put it here. At the left side, we're going to have 2 and 1. First, we're going to put a 2, and then we're going to check this 1. 1 is at the right side of 2, so 1 is going to be here. Yeah, so this is we can turn this tree into an array, and now we're going to append value 3 at the right side. I mean after the array, and then we're going to use this kind of array to build a tree. And how can we build it? It's exactly the same. First of all, we're going to find the maximum value. It's going to be 5, and then at the left side it's going to be 2 and 1. It is here. At the right side we have 4 and 3. We're going to first find the maximum value 4, and 3 is at its right side, so 3 is going to be here. Yeah. So if we understand how can we build such kind of a tree after appending the value, so definitely we can solve the problem. Yeah, we're going to use our DFS to solve the problem. So while running the DFS, we're going to compare this value, the value here, with the root value. Yeah. So if this value is more than the root value, it means this value is going to be the maximum, because if this root value is the maximum up to now, if we append value, maybe it is 6. 6 is more than 5 here. It means this value is going to be the root value. So we're going to just prepare the root node as the value 6, and the left side of the tree is going to be this node 5. And we just finish the function. Everything is okay. But what if we just need to append a value? It is not 3, or maybe maybe it is 3. Let's just use the 3. What are we going to do? First of all, we're going to check, because this 3 is less than 5, definitely we're going to go to the right side instead of the left side, because 3 is at the right side, at the end of the right side. So definitely it will go to the right side, and then we're going to compare this value 3 with this value 4. So 3 is less than 4, and then we're going to go to the right side. After that, if the right side of node 4 is empty, we just need to append this node 3 as the right side of this node 4, and we just finish the function. Now let's just maybe check the third example. Maybe let me just try to use another color. So first of all, we have this node 5, and our value is 4. So as 4 is less than 5, so we're going to go to the right side. Yeah, if we go to the right side, this value 4 is more than 3, so this 4 going to be the root node. And the 3, as this value 4 is at the right side of the array, or at the right side of the tree, so this is 3 going to go to the left side. Yeah, so 3 going to be here. Yeah, because currently 4 is the maximum, definitely this one going to go to the left side according to our function when we turn this tree into array, and this 3 must be at the left side. Maybe let me just use another example to explain it. Maybe first of all, we're going to have a 5 at the right side. We have 3 at the left side. We have 2 and 1, so 2 going to be here, 1 is the right side is here. So after we append a value 4 will be here. So 3 and 4 will go to the right side. So as 4 is the maximum, 3 going to be the left side. So this is why we can solve it like this. Now let's just finish write the function. So if you understand the process, normally the functions would be easier. So if not node, it means it will go to the end of the tree. We just need to append the value. So we're gonna return a tree node with the value, which is gonna be this value. Yeah, it will go to the right side. Otherwise, we're gonna check the value. If value is less than value, it means this value gonna be the maximum. So we just need to return the tree node. So we're gonna return the tree node. So the value gonna be our value. At the left side, it's gonna be this node. At the right side, it's gonna be none. So I don't need to write it. And now it means the node exists, but the node.value gonna be more than this value. So what I'm gonna do? I'm gonna call the recursive function. So the node.write gonna be equal to the DFS node.write. So I'm gonna check the next node, which is gonna be the node.write. So if it is none, so I'm gonna return the tree node. Yeah. So this is for the second example. So if we go to the second example, so we're gonna continue to check 5, 4, and then it's gonna be as the value 3 is less than node.value 4, so it will go to the right. So this node 4.write is going to be DFS node.write. Yeah, as the DFS node.write gonna be empty, so we just return a tree node which is gonna be 3. So we're gonna append 3 to the left side of the node 4. Finally, we just need to return the node. Now let's just call the function and to check if it works. As you can see, it works and it's pretty fast. Thank you for watching. See you next time.